Okay, guys, welcome back. Please, if possible, turn on your cameras. So let's start. Previous lecture, we was talking about this paper, Stepwise Refinement, and we start reviewing a small example. It's like, okay, programming is important. You need to know a programming language. But then we start with these problems of having a lot of lines, of we need to split the problem in parts and connect the parts. And 9070, the problem, the parts, functions. We have lines of code, and instead of having a big main, the first problem is, well, let's split the main in different functions, different methods. How to create functions? What is the criteria to split one main, put everything together into functions? Well, we start talking about the key idea. The key idea is a function, is a task. So if we can identify in the problem different tasks, we can create one function per task. The collection of functions, the collection of tasks solve the problem, our project. Inside of the task, we have steps. Our steps are going to be our instructions. Our instructions, basically three categories: conditions, loops, or one line. One line being an expression, an instruction, or a call to a method. That is the key idea with this paper. Initial step. Now, we start working, and it is very simple, the concept, but there is always the question, well, yeah, split lines of code into several methods, but what is the criteria? How I do that? How do I know that what I am doing, splitting these lines into this collection of methods, is a good decision or not? If there is another different solution? Well, two criteria that I want to review with you, following with the example that we start reviewing in the previous lecture. Number one, there are different ways to do this. The one that the paper described, the one that I want to apply today, is this idea of top-down. We reviewed this before. The author suggests the top-down. We reviewed these three. We have a problem, and we need to go down. Go down to this, the leaves, the last level in the tree, and those are the tasks. Those are what are going to be our functions. In the middle, this, or maybe more nodes that are between the root and the leaves, they are just conceptual things that we are trying to understand, ideas that we have. In the example that we reviewed in the previous lecture, if you remember, I asked you to solve a problem, and I am sure that you identify immediately two things, two problems in the problem, two subproblems. I asked you to do something similar to a compiler. I asked you to read a file and translate that file to another one. And for those of you that are familiar with this, I was basically asking for lexical analysis, reading a document and split that document in the words that are there, and syntaxis or syntactic analysis, create a tree, and then translate together for the small project that I suggest. Those are these two. But still, talking about lexical analysis and maybe translation, like two separate problems inside of the project, well, we start working with this. I asked you to do at homework about this subtask, 50% of the project. And it's like, well, you need to read this file and you need to do something with the thing inside. What do you need to do? And we agreed that, well, we need to read and we need to split and we need to classify, something like that. Those were subtasks of the lexical analysis. And finally, the decision for you was, well, maybe these ones, reading, split, classification, those three are the methods that you need. So from the problem, at least we identified three methods. Always, if you think that something could be a method, ask, what is the responsibility of this method? If you can ask, what is the responsibility of this method? And you can answer that with one or two sentences. If you can explain what that method is going to do, why that method exists, check, that is a good method. If in your explanation, you mention more than one responsibility, oh, this method is doing this and this and this, that method needs to be separated. One responsibility, one task, one method. That is the goal. Why? Because later you can reuse that method, because that method do one and only one thing, like a Lego block, one thing that can be reused. Hopefully the theory is like, well, makes sense. Practice. We have this problem, this input, and we want this output. And I am pretty sure that you did your homework and you start working. Because you start working, my assumption is that you solve the small problems, like what do I need to do in order to read a file in Java? What do I need to do in order to tokenize a string? Those problems, talking about programming, is something that I am assuming you're familiar with or you have the opportunity to research. So I can talk here about the design, not about the programming, even though I am going to show you some programming and then we can complete this. Programming. Hopefully, at least, you start working with this problem and you start writing something like this. If I am a programmer and I am new programming, it's like, well, let me start with doing a class and let me start with doing a main method. And inside of the main, I can start doing programming and I can try to solve whatever they are asking me to solve. And well, someone told me to put comments in my code. So maybe you put comments like the one that I highlight. If in any moment you're adding comment like the one that I put here in black to your source code, basically what you are telling yourselves is, here what I need is three methods. This should be a method, these lines. This should be another one. This should be another one. These comments as a titles inside of the source code is basically asking you to refactor that, create methods. So use a hint. Anyway, as you notice, it's like, well, as a programmer, maybe something that happened is I need to read the file. Then I discover that I need some classes in Java. And there are classes that allow me to read a file, and in particular a text file. And after reading the text file, I have access to each of the lines. That is something that I need. And the first step here is, if I need to read a file, it's a good idea to put that file in the memory. It's a good idea that whatever is going to happen later, my first step is read the file, put the information into the memory. Why? Because it doesn't matter what I am going to do with the information. It's going to be easier if that information is in the memory. Working with the information at the same time that I am reading the file is usually not a good idea unless the information is big, a lot. That is not the case here. So read the file, put the file in the memory, and then I can continue, because all the next steps are going to work with that information that I already get in a first step. A second step, we need to split the words. And if you play with this, what you need to do is split the lines. Maybe it's a good idea to split the enters. Some of you maybe want to work with everything like one line. I am going to tell you why I select this option later, but split the enters. And then I do not know what I am going to do, but hopefully you notice that you need a loop. Because whatever you do with one line is like, well, I need to do exactly the same with the other. So I put a loop, and inside of that loop, what I am going to do is to process the lines. Here, I didn't put this like that, but in order to process the line, it's going to happen a lot of instructions. Here, a lot of conditions. A common practice, something that you want to do. If you're going to have a lot of lines inside of a condition, or if you're going to have a lot of lines inside of a loop, that is telling you, please create a method. Why? Because like here, it's like I have a loop, and instead of having a bunch of source code inside of the loop is going to be calling a method. Did you notice? Two decisions. Number one, if I have titles, create methods. If you're going to put a bunch of lines of code inside of another structure, conditional loop, create a method. It's a different task. And this continue. Option number one, you have a programmer and your programmer give you this code. One method with a bunch of lines that somehow you need to read, and they, well, maybe make sense. The comments help you somehow. This one or this one. Let's be clear. If you're reading a program, the first thing that you're going to do is read the main, period. If I give you a program and I ask you to review the program and tell me what the program is doing, the first thing that you're going to do is go to the main, see what the main do. Read this main or read this main. Which one is easy to read? Which one do you prefer and why? Ideas. I am solving the same problem. Hopefully you notice that. One or two? Okay, thank you. Good. Hopefully everyone agree with those that are telling me two, the second one. Did you notice that the second one do not have comments? Did you notice that basically the second one, the source code is telling me what is happening and also doing that to happen? Recommendation. When you're doing a program, yes, I know that they teach you in 110 to put comments to your programs. Yes, I know that you know the several different ways to put comments in programs. The best source code is the source code that do not have comments, because the source code do not need the comments. Put a comment when the comment is needed. And if you need to put comments, that means that your programming, your source code, cannot be explained itself. If you read this, you think that your brain is asking for comments? You think that you need comments? It's like, oh, this is very clear. What is happening in this main? Three things. I am reading a file. The path is a parameter. I am splitting words. I do not know what is that, but split words from the text that is the parameter from the previous method. And then I am going to do something that is translate. With what? With the tokens that come from the splitting the words. 3 lines. You read the lines. No comment needed. Moreover, if you know that the first thing that the reader is going to do is to read the main, this is very clear. If I want to know more details about the program, I can go and read the source code of the methods involved. It's like how the translation is going to happen, how the split word is happening, or even the reading the file. But just with this, I know what happened. And this main is the top of my solution. That is the root of my solution for the problem. I can tell you, the program that you ask us to do, this program to translate from here to here, the only thing that I need to do is this. Yes, I know you are thinking like, well, yeah, that is the big picture, but what about the details? You go down the tree and the details are down. Do not put details at the top. Do not put details reading the file in the main. That should not happen in the main. Think about this reading the file, for instance, these lines, like steps, details for a particular task. What I should read in the main is the tasks that are involved, not the details. Rule number 3, good? Okay, fine, this is your main. I go to the details, I need to go down. I asked you to do this. This was your homework, hopefully you did it. So that saved space in my slides. We can review details if you want, but in general, things that are important. Oh, reading the file. You know what? Reading the file. I am going to read a file. What do I need? My input, and what I am going to provide, my output. Inputs, outputs. Always, 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 when you define a method following this approach, you need to define what I need, what I am going to receive from someone else, I don't care who, and what I am going to return. Be clear. I am working with this team of functions, but the first thing that you need to do is, I don't care what are you going to be doing, or you, or you, or you, is tell me what I need to do. You need to read a file. Okay, in order to read a file, I need the path for the file. Who is going to tell me the path? Parameter. Okay, I am going to read the file, I am going to put the file in a variable, and I am going to return that variable. I do not care what is going to happen with that information. That kind of idea is what you need to consider when you do a method. Never, never, never put two methods or more that are in dependency of each other. That, okay, I am going to do this, but only if that guy do this other thing. If that other guy fail, I am going to fail too. But it's the responsibility of that one. Yeah. My responsibility, this one. My inputs, these ones. And if I receive that input, I provide its output, period. I am done. The path, with the path, you know, open the file, read the file, return the information. I am done. Okay, someone else is going to use this method, is going to provide the path, and is going to store the result in a variable. Two different tasks, two different responsibilities, done. Question. This method, 3 lines. What is the complexity of this method, this main? Do you remember that we talked about complexity? In particular, cyclomatic complexity in the previous lecture. Can you tell me cyclomatic complexity for this method? It's something that we need to check, because remember, there is a magic number about, hey, be careful that the cyclomatic complexity do not go beyond this point. 1, thank you. 1 is the lowest possible, right? So this method is 3 lines, easy to read. Cyclomatic complexity 1. It's a good method. What about reading the file? Number of lines, well, 6 is small. It's clearly small. Cyclomatic complexity, I agree with you too. How do we know that these 2? Well, I put in red the while, and you know, condition plus 1. Yeah. So it is clear that reading the file is a little bit more complex than the main. Yeah, because the while. You could agree with that. Still small, and still 2 is a lot lower than 10. Fine. Split the words. Split the words is the next step. Split the words is something that is going to happen. And again, the input for this is the output of the other. And a new output. The source code here, you have it. Hopefully you did it. Important things that I am sure you have here, a loop, for sure. You're receiving this, according with my example, this string, a big string. And one of the first things that I am doing here is, well, split the lines. You notice that some validations are needed, like what happens if there are not more lines, if the line is empty and so on. You solve that in some way, but there are going to be need for some if conditions inside of the loop. That is the thing that I want to show in the slide. Is you need a loop to process the information. Inside of that loop, you're going to have if conditions. If conditions for simple validations. Hopefully you did it and you noticed that. But also, in some point, to split the words, to recognize the words. Two options. Number one, a lot of code there, a lot of conditions, by the way. What we did before, what you can do here, the another level. This one is reading. This one is going to split. The one that is going to split need help. Need help because here, there are a lot of source code. Source code for what? I have the line, or I have a particular, sorry, a particular string, and I need to check the words. Or I need to check, okay, this is a word. What is this? I need to classify. I need to find the token for the particular word. Different ideas. But one thing that hopefully you agree is we need help. We need what later is going to be, we need a delegate. We need a helper. It is my task. It is my responsibility. But my task is too big. So I am going to do this. But in this particular part, usually inside of an if or a loop, I am going to give someone else, here, work with this, help me to do this small part. Report the result back, and I am the responsible, but someone else is helping me. Someone else is my delegate. It's going to be the case here, or it could be the case there. And we have a tree with 3 levels now. And still, we need to work with the translate. That is a different problem. Translate. This guy, the one that is going to help me, what are this guy going to do? Well, that guy is going to create a new token. That guy is the one that I am going to give him something like a string. And somehow I am going to identify what is the token, what is the category for that word. You can imagine that the important things there, a bunch of if-else. The same if-else that you can put here, but in a good design, you split, you create a new method. Yeah. Here, there is not only one solution, guys. There is no, this is the solution, anything else is wrong. 2 ideas, and maybe you implement one or the other. The only thing for sure is you are going to have a bunch of text from one method, the one that is going to read the file. Second, you have another method, and this method is going to split. Whatever it means, split. Option number 1, a method that split the lines and have a helper to split the words. Option number 1. The only thing that I am going to do is to split the lines, and I am going to give the line to someone else. You are going to do the rest. Option number 2. You know what? Okay, I am going to split the line, Also, I am going to split the words. And when I have the word, I am going to ask for your help to classify the word. I am doing two things. I am asking for help for one. Or I am doing one thing and I am asking for help for two. Both options are possible. You are the ones with the story. You are creating the storyline. My point is you need to split. Why? Because if you notice, if you try to put together all the split lines and words and classification together, it's going to be a long, long method. And that is not what we want. Why? How do you notice that it's a long method? Two things. A lot of lines of code, but second, the cyclomatic complexity is going to go crazy. What is the cyclomatic complexity of this method? It's going to be 1 plus the loop, and I am sure that I need a loop, plus the number of conditions. More conditions here, cyclomatic complexity increase. What could be better? To have one method with cyclomatic complexity 20, or having one with cyclomatic complexity 10 and another with cyclomatic complexity 10. Use splitting into not particular algorithm. Can you agree with me that two methods with complexity 10 is better than one of complexity 20? That is the reason because we're searching for this task. That is the reason because we're creating these three. We do not want one method of complexity 20 because think about it. We have this program with all these methods, and you are the programmer that is going to review this method. Oh, sorry, the method is complexity 20, but it's your work. Versus, okay, you review this, complexity 10. Someone else is going to review this one, complexity 10 also. Split the work to the complexity 10 is better. How do you achieve complexity 10 or 9 or 8 or whatever? Probably there are going to be small differences between the decisions that one person takes and the decisions of another. Again, maybe in one solution, one method is splitting the lines with the enter and also the words with the space and the limiters. And the other method is just classifying the word. In a different approach, one method is just splitting the lines with enters or whatever, and the other method is searching for words and also classifying those words. Depending on your programming, depending on your approach, both cases could be possible. As far as your methods are small and have low complexity, they can work. So far, so good. What we have right now with this is we basically solved this. What you did as a homework is 50% of my original problem, right? What you did is, okay, now you have the source code in Java for reading the file, store the file, split the lines, split the words, and somehow classify those words into names, keywords, delimiters, and so on. You have that. And the only thing that I am asking you to do is loops, conditions, a lot of conditions, and knowledge of the Java API, maybe Java EO for reading files and working that. That's it. Other than that, data structures, you notice I use vectors, but vectors in general, you can be using arrays, templates, vectors of strings, maybe another class token to store the things. I didn't go to the details, but I am sure that your programming skills allow you to complete this part. Second, okay, you are done with this. You have in a data structure all the words, and you have in that data structure the category of the word. That was the first problem. Second problem, we need to do the translation. Translate is the second part of my problem, right? It's the other half. And it's like, okay, what do we do to complete this crazy idea of translating from this to this? Second approach to take decisions about methods. The first one is task, sequential task, small, one name. The next one, the reason because I choose this example. The next one is, I do not want to be responsible of anything else, just one thing. Is this approach in which you are trying to define what is going to be your responsibility as you are the method, and basically this idea of I do not care about the others. You need to do a translation. Tell me, what can we do if we want to translate this to this? We already have the words in a data structure. In a data structure, you have this idea of main. You have this idea of open parenthesis, closing parenthesis, curly bracket, home, if, open parenthesis, closing parenthesis, curly bracket, and so on. You have all these words separate. Moreover, for each of them, you have the classification. You know that, okay, this is a name, this is a delimiter, this is also a delimiter, this is also a delimiter, this is a name, oh, this is a keyword, and so on. This is what you have. This was the result of what we already did. What we do to go from this data that we create to this. The solution is important, but most important is what method we need. Okay, you are thinking about the solution, the stack. You are thinking about the stack because basically this solution, the syntactic analysis, the creating sentence, if you remember, you need a tree. And for implementing the tree, you have two options, stacks, recursion. Stack, recursion, trees are concepts that are connected, right? The solution is going to involve something like that, somehow stacks or trees. But methods, task, which are the tasks here? In the previous example, for the lexical part, the tasks were sequential. Very easy to identify is I need to read, I need to split, I need to translate. Here, the tasks are not sequential. And because they are not sequential, probably it is hard to figure out which task we need to do. The problem, that one, translate. Before translating, something that we need to do is to identify the elements. We need to identify here the methods, this main and home, right? We need to identify these instructions like home, whatever, something. We need to identify when we have if conditions like this orange if or the green if. We need to identify when we have while conditions. That is what I need to do. I need to identify those elements. When I identify the elements, then I can translate them. Yes or no? And immediately you are thinking like, well, yeah, you're going to identify them, but several of them have other elements inside, like the if have inside another if, and the while have inside another while, or the while have inside an instruction. Yeah, but what if my responsibility one method. My responsibility is going to be to identify if conditions, period. That is my role. I am going to tell you if there is an if condition, yes or no. If I detect an if condition, I am going to tell you that. Moreover, if inside of that if condition there is an instruction, I am going to call to the guy that is responsible for the instructions. If inside of that if condition is a loop, I am going to call the guy that is responsible for the loops. I am going to do my work, but if I notice that I have on my hands something that someone else is working on, I am going to share that with that guy. Do my work, and anything else, anything that is not my responsibility, send to the proper handler. That is the second idea with the methods. If we follow this idea, it's like, okay, professor, are you talking about something like the following? We have a method, translate, but then we need to check for methods. We need to check for if conditions. We need to check for whiles. We need to check for instruction. Whatever checking is, review the structure. So we need to create those 4 methods. And my answer is, yeah. Think about it. You're going to do a translation. And the translation is going to have down subtask. Subtask, translate methods, translate ifs, translate whiles, translate instructions. And if you're thinking like, can we follow this approach to create a full compiler? Yeah, you can follow this approach to create a full compiler. Check classes, check for do while, switch, and so on. Okay, how this is going to work? Because the idea looks like, fine, okay, translate and you have a lot of methods. Good. And then, well, think about it. We are here, and at least in theory, the first thing that is going to be in the file is a method. If we do not have a method, something is wrong. You can stop. The first thing that I am going to have when I start translating is a method. My method translate, when I ask for the translation, the only thing that translate needs to do is call the method. Now, how many methods can I have inside of my example? Here I have 2. Can I have more? And the answer is, yeah, of course, you can have more. What I am doing here is kind of a document that is similar to a class in Java. Okay, how many times translate can do check method? What about a do while here? So check the method several times. How many times? You need to figure out the condition there, right? What could be a good idea for the condition there? It's like translate, it's going to be searching for methods, searching for these big paragraphs. How many times? Do we know how many times? What can we do to figure out how many times? Basically, when this loop stops, the translation process stops. Yeah, thank you. The end of the file. Well, the end of the file, but we are not reading the file. Remember, for translation, our input is this vector with all the tokens. Do we know the size of this? Do we know the size of the vector that have all the words with all the equivalent category? And the answer is yes. We know the size of that vector. Here, we stop when we process all the tokens. when we read all these elements, we know the size. Can we create a variable, a counter? And can we put that one in 0? So we are going to start with the first one. We are going to start reading word by word. Each word is one element in the vector. And can we stop here when that counter is not longer lower than the size of the vector? Because basically we finish with the file, we finish with all the elements that we load. And the answer is, yeah, we can do that. Okay, so that means the translate process, my work, is basically having a loop. And as long as I have elements in this vector, I am going to be calling another method that is going to review if there are methods here. Yeah. And that is going to happen 2 times for your inputs. But there are more things there. There are ifs, and there are lines, and there are whiles. I don't care. The only thing that I do, the translator, is taking care of calling 2 times this because I am assuming there are methods there. My work is to call the guy that is going to check for the methods. That's it. Check method. This method, can you tell me what this guy is going to do? Can you figure out the instructions for check method? Let's see. My responsibility is to review if something is a method. What is the first thing that a method should have in my example here? First thing for a method, a name, parentheses, and the curly brackets, right? What can we do in order to check that? Conditions. Conditions. We have this vector with all the words. And I want to read the first one. This is the counter that initially is 0. I am reading the first word in the file, the first one, the current one. And I want to check if that word, not the word, but if the type of that word, the category, remember? We have this table, and the word 0 is main, and the category is a name. You have that information in some place, some data structure. The first thing that I do is check if the type for that guy is name, if that is the category. No particular language here, I am just giving you the idea. What I do if I am reading the first word and the category of that one is name, and that is what I am expecting to be. What I do? This if condition is true, next. One thing. You have 2 options. Number 1, there is an error and you need to report. If that type is not named, you have an error, you report the error. throw the exception. But if that is correct, if the if is true, the only thing that you do is move to the next word. Increase the current word. I am going to put there a comment. Here, you can handle the error, throw an exception, print an error on the screen. I don't care. It's just there is an error. And you can do a system out here and just stop the program. Up to you. Step number one, the first step in the task of checking for method is this if condition. Two options. The word is correct, go to the next word, increase the counter, or there is an error. Can you imagine what is going to be my next step here? Can you agree with me that my next step here is going to be exactly the same that I had before? The next step in this check method is another if that basically is going to check that the current word, that obviously should be the second one because we already increment here, is a delimiter, and that delimiter is in particular the closing parenthesis. And again, you have two options. That is true or not. If that is not true, if it's not the open parenthesis, you have another opportunity for error. But if that is true, if that is the open parenthesis, just like before. Makes sense. Help me. Next step here. Another if. What could be the condition for the step 3? If what? The current word now is closing parenthesis. And what could be the consequences? If true, increment the counter. If not, an error. What is going to be the next step here? If current token, the open curly bracket. If so, increment the counter. If not, error. Okay, finally, we are here in this important moment. So far, our conditions, checking the name, the open parenthesis, closing parenthesis, open curly bracket. After the open curly bracket, what can we have there? Anything. What is the meaning for anything in our particular scenario? Can you agree with me that basically that anything could be, yeah, you could have an if, or you could have a while. I am not giving you the full condition, just kind of the idea. You can validate if you have that, right? Or you can have something that is a name, nothing in particular. This name could be an instruction, like the example that I showed you before, or could be the name of a method, a name. Option number 1, option number 2, option number 3, option number 4. Tell me, what happens if we do not have the if, we do not have the while, and we do not have a name? So what happens if we are in the option number 4? Thank you for that. The other option that we could have is if we have the closing curly brackets. And then we have if we do not have the closing curly bracket, if we do not have a name, if we do not have the if we do not have a while, if we do not have any of those elements, we have an error. And again, throw an exception or report the error, whatever, it's an error. What if we have the closing curly bracket? If we have the closing curly bracket, my work is done. Because remember, I am the method check for a method. And if I already did all my work and finally I am reading closing curly bracket, this is a happy return. I am done. I complete my responsibilities. What if we have an if? What if I am reading the word if? What I do? What I do? I am reading a word if. This is not my problem. I am going to call to the guy, to the method that have as a problem to review the if. What if I have a while? What if I have a name? Did you notice the idea? My responsibility, this method responsibility is to check for methods. The elements that I need to review, like I have a name, I have an open parenthesis, I have a closing parenthesis, I have an open curly bracket. Those things that I need to review, I review it. I use conditions to check that those elements are there. And if those elements are there, I move forward. If they are not, I report an error. And someone else is going to take the responsibility of stop this or continue with the error, like your compilers. But then, when the things become complex, when I need to check for, I have an if, and I know that if is the open door for something else complex, I delegate the responsibility to another method. Okay, I do not have the if, I have the while. Delegate the responsibility to another method. I have something else, a name, a word, whatever. Delegate. I found the closing of my responsibilities. The only thing that I need to do is to return. That is the end of this method. I did my work, return, I am done. Error. Makes sense. Complexity of the method, cyclomatic complexity of this guy, more or less. The number of conditions plus one, right? 1, 2, 3, 4, before 1, 2, 3, 4, around 8, 7. You can improve this, but we are below 10 yet. It's a good method. Moreover, do we need comments to explain what is happening here? My writing is not clear, but if you read this, it's like, well, makes sense. It's searching for the name, it's searching for the parentheses, it's searching for the curly bracket, and everything else, call another method. Hopefully you agree with me, no need for comments. Well, remember, the only thing that you put mandatory for any method is the comments that go outside of the method. Javadoc this comment that is a summary of what is the method is doing, the parameters, and the return. What is my input? What is my output? What I am doing as a summary at the top. That Java documentation is useful because with that Java documentation, you can create the API documentation. That is the only reason. It's the documentation for your web page with the API documented. But comments inside of the source code, comment inside of the lines that are the body of the method, no need. And that is good. Following this approach, can you imagine what is going to be the content for the method check if? What a method check if is going to do? Can you program check if? If we follow the idea that we follow with check method, could you agree with me that the first thing is going to be an if condition? And that if condition is going to be something like, well, in the array or vector or whatever words, the current word is equals to if. Then I can continue. If not, it's an error. True, increase the counter. False, the error. What is next? Could you agree about checking for the open parentheses? What is next? Could you agree checking for the closing parentheses? What is next? Could you agree checking for the open curly bracket? What is next? The important part. The important part. Can you agree that is checking for option number one? What if being here the word, current word, is equal to an if? I am inside of the method if, and I already checked the parentheses and the open curly brackets and so on. So now I am here for the body of the if. And in the body of the if, I am just detecting if, which means I have an if inside of an if. Thank you. What I do? I am going to call the guy that checked the ifs. It's myself. Okay, I am going to put this task to me, to a clone of me, to another copy of me. That is recursion, right? When you call a method, you are creating a copy of the method, even if that method is yourself. Recursion. That is your stack. The recursive calls is a replacement, as an equivalence of another solution that is also viable using stacks. What is going to happen? This method is going to be there in the memory. I am here still working, but I am calling another copy of me that is going to work and do the if that is inside. My only work thinking about the split responsibilities is I am doing an if. I am finding another if inside. I am going to make a recursive call. Other options, else, if. I have a while. I am going to call the guy that handles the whiles. Another option. Another option. Calling the guy that handles the instructions. Calling an error. Or, obviously, if I found the closing curly brackets, use return. The closing curly bracket represents that I finish with my responsibilities. Did you notice that it's almost the same that I did for check method? Checking the initial things, checking the body, The body is the complex part. What do you think about check the while? Can you imagine the source code for check the while? We're going to check the name, the open parenthesis, the closing parenthesis, the open curly bracket, and then the body. And we're going to be there until the closing. We need a loop here. We work with this method, more or less this one. And I am sure that you can figure out the other methods. If we do those methods, and if we put this together, what we have so far is lexical analysis, the words to tokens, the words to the word and the category. What we did right now is the tree that represent the sentence that I have here. I am able to identify that this if is inside of this method and this while is inside of this if, because I am creating this tree, the stack that is created with the recursive calls. I just split the responsibilities in something that is very simple, and each of them represent one single task. If I ask you what is doing the method check if, is checking if an if is correct. But an if can have if inside. The method check if is able to call itself recursively if detect another if in the body. The same for while, the same for method. Well, method is not recursive because you cannot create a method inside of a method. You can do a call to a method, but that is a different story. Instruction. What you are going to have in instruction? Will you agree with me that it's going to be only one if? If the current token is equal to a string, a name, then increase the counter, else report an error. That's it. Only one element. What about the translation? We have these methods, but we're missing something. I need to print these elements on the screen. Tell me, which method is going to be responsible for printing this open bracket? Where in the program that I described, we need to add a system out println this. Where? Which method? In which line of that method? Can you imagine? Check method. Yeah. Check method. Oh, okay. I have a draft of check method here. Check method. Where in this bunch of lines in check method I can print this open bracket? Any idea? After. If I have here a name and I have here an open parenthesis and I have here a closing parenthesis and I have here an open curly bracket, can you agree with me that exactly here in this point, before starting reviewing the body, I can just do a system out println. Oh, let's avoid the ln. We want a line. Can I do that? How do you know that this method? Well, because this is the method that is reviewing for methods. How do you know that is exactly in this particular position? Well, because according with your instruction, when you have this, all this, you create this. One more step, printing something in one of the tasks. Check the methods. Where, in which method do we print the closing bracket? Maybe in the same check method. In which position? After we detect the closing curly bracket. Can you agree with me that this is something that you can do exactly here, just before the return? Remember, the return is because I finished with my work. Well, before you finish with your work, what about reporting that you finished? Did you notice that the first one that is going to print something is check method, but also it's going to be the last one because everything else is inside for that particular method? For the other. Following the same ideas, can you tell me who is going to print this minus? Where we're going to put this print the minus? Where we're going to put this print or the print for this? Because those are the other things that we need to complete the translation process. Parentheses and parentheses, those are the things that we need to print. The only thing that you need to figure out is system out println these elements, where those instructions are going to be, right? If you get the idea and you can complete the steps of the tasks that we define, you are done. You have a translator from this to this. You solve the problem. Moreover, you do not only solve the problem, but you have very specific methods that you are able to explain what they are doing. And all of them are doing one and only one word, recursive or not. And all of them, for this problem, they are small. The number of lines of code that they are going to be inside is lower than the limit that we defined before. What is the maximum number of lines that we want in a method? Do you remember? Yeah, they are going to be lower than 50. Moreover, they are going to be lower than 10 in cyclomatic complexity. What we did today, this is a design. Even this is almost pseudocode. I give you the blueprint. It's not a class diagram. It's just a tree, a connection of methods. And for some of those methods, something that could be pseudocode, maybe I could have done a flowchart diagram, whatever. But hopefully, I give you the idea. And hopefully the idea is clear. Yes or no? Okay, I have 2 yes. Well, 2 of 52. I have 50 people thinking. Good. Okay, so summary, stepwise refinement. Split the problem in task, only one task. That task should enclose loops, conditions, and sequential instructions. Sequential instructions include calling another method, though recursion is also one option. That is paper number 1. And just to be sure that this was clear, I have homework for you. Your assignment number 1, please. Assignment number 1, source code programming. Yeah, this is software design. Hopefully you understand the design, the idea. In order to be sure that you understand that and you're able to put that design in practice. Assignment number 1, source code in Java. Source code of what? The compiler that we use implement. A program that do what we have been reviewing the previous lecture and today. Please do the source code, do the implementation. You can work alone or you can work in a team of 2, not 3. One, you work alone, or you can work with someone else. So you can work in pairs. 2 people or 1 people, complete the assignment. You already start with the lexical analyzer. It's something that I ask you to do for today. If not, you have the opportunity to complete that. Do what we described today, complete the translation. Obviously, it should compile and it should work. If you submit something that cannot compile or didn't do anything, it's going to be 0. This is not like CSI 110, you submit something and we give you points for some if, else, loops and things that do not work. It should work, it should compile. So be sure that when you submit the last version, the good version, the one that you want us to grade. I am asking you to apply good practices for readability. Moreover, I am asking you to use Javadoc. If you're not familiar with Javadoc, please review it, ask to the TA or to myself. I am sharing with you also guidelines about how to work with Java, good Java techniques, particularly names for the variables, structure of your code, indentation, and so on. I am assuming that you're familiar with that. If not, review it. But please, your code should show that you are professional engineers, right? So any question, let us know before the submission due date. You should receive the file, the input as a parameter to main, and basically you print the result on the screen. When we run your program, we run in the command line, your program, parameter, the input file, and we get the output. This is your homework. You have 1 week. Good? Any question? No, it's the same grade. You can work alone or you can work with another person. You can be a team of 2, and the grading criteria is exactly the same. It's not going to be any difference in the grading. Go ahead.
Professor, when the check method is looked at, it is also delegating the work to check if and check while. So is it not a violation of the single responsibility principle?
Which one?
The check method.
Well, the responsibility that those have is, as the name, right? Is checking for the if, checking for the while, checking for things. When something that I read is something that I know could be responsibility of someone else, what you do is calling that someone else that have that responsibility. Let me be clear. Here, in the checking for the method, when I read in the body the word if, the only thing that I did was to call the method check if. Just because it's like, well, I am working here, this is the body, this is not my responsibility, but okay, it's an if. I am going to call this guy checking for the if. And the guy that is checking for the if, I put this checking that really the word that is there is an if. Even though the other guy sent the work to you, it is my responsibility to check that, okay, I was called, but really the word here is the if. Yes, okay, I continue my work, or I report an error if was not the case. Checking the input and checking that I am ready to work is my responsibility. The other guy is just delegating things, and it is perfectly fine. You can have not only one, but several delegates. In this case, checking for method have as a delegate the check for if, the check for the while, the check for the instruction. That is fine. Okay. Because my responsibility is I am checking the method and delegate any other thing. Okay. That is kind of the reading here. Good?
Got it. Thank you.
Welcome. Okay, guys, so you have homework. 1 week. I am going to put the link on Canvas, but you get the idea. Do this compiler alone or with a team, and please, good code. Something that is easy to read, something that shows your skills in software engineering. Yeah, I am kind of getting open with exactly the implementation that you're going to get. I give you some ideas here, but be careful. Several things that I explained here, I am missing loops and I am missing some validations. So I am giving you not only the homework of completing these lines, but you are going to need to fix things. And I am doing that to be sure that you understand the problem. This is not just translate or complete my code, but there are things that you need to fix. In particular, here, we check the method. Hopefully you notice that whatever is going to be here in this block, the body, is not going to be used those if else, but these guys need to be inside of a loop because you can have more than one line or more than one instruction inside of the method. For instance, you can have 5 ifs consecutive as a body of a method, and that should be possible here. So you need loops and other things, yeah. Yeah, remember, too many if else. Each if is a condition. Each condition increase in 1 the cyclomatic complexity. So we are thinking about 10 conditions, 9 ifs is in the borderline of what we accept in the complexity. Here, don't worry, you're going to be below 10 because the language that I define is very small. What is going to happen later if I decide to increase this language to something more close to Java? That is a different story and another paper that we need to review. Good? So homework, you have 1 week, and the other homework, if you haven't done this, read the second paper. We're going to talk about the other paper in the next lecture. And somehow another homework is going to be put the content of that paper, the ideas there, to maybe improve a second version of this software. Good? Okay, guys, any question? Yeah, only for the assignment, the only thing that you need to check are programs like this, which basically are methods that do not have parameters and do not have return types or scope. Inside, the only thing that we have is instructions like home that do not have the semicolon yet. If and whiles without anything in the parentheses, they are empty, but they have the parentheses and the curly brackets. And inside, they have more if, more whiles, or what we call names, instructions, again, without the semicolon. Only this language. You do not need to go to a full Java compiler, maybe later, not yet. Okay, guys? Yeah, this is the output. Use the symbols. For the program, you have 1 week. For the paper, next lecture, we're going to be talking about the paper, so read the paper before the next lecture. For the program, you have 1 week. Good? See you next lecture. Thank you.